I'm going to be deleting this video almost as soon as it's done, well, sometime today, but the source videos are in the description if you want to see. This is pretty insane stuff. I saw this a long time ago. Basically, it's asteroid discovery from 1970 to 2015. Here it is. This is real. So it starts off in 1970 here, and as time goes on, this is our solar system here. There's the sun in the center. And as you can see the planets moving around, I'll zoom in a second here, but as you see the planets moving around, and as you see time goes on, you'll see the number on the bottom left start to increase. That's how many known asteroids we've found. This is real, by the way. This is based on real data. This is not just some guess. And we can zoom in. This is an 8K video. You can see nice high quality. Third rock from the sun, of course, is our planet, the Earth. And you'll see these are colored. And that means something. So you'll see as Earth spins around, our cameras are pointing at the sky, taking pictures and finding asteroids, you know, in space. So let me zoom back out here. So this is 1979. And I'm going to skip ahead. This is kind of a long video, but as time goes on, 1986, starting to get a little more. In the 90s, we start to get better technology. So let's see. Around 94, you know, shit's starting to really pile up. When you see red and yellow, those are more dangerous. That's like inside of Mars' orbit, and the red ones I think are inside of Earth's orbit, something like that. But they become more dangerous, and you'll see there's a pattern here of physics that as these objects, these asteroids, come in near to our planet, they get flung out. If they don't hit something, they get flung out. This is actual physics here. And way on the outside ring is Jupiter. And now look at this. In 99, 2000, we start getting better camera technology. And we start to realize, holy shit, our asteroid is, or our solar system here is a shooting gallery. It really is. Which is exactly what Neil deGrasse Tyson said it was. And this is a good visual representation of that data. It's kind of scary, but we are really surrounded by this many asteroids. Is this fun? No, it's not, but it's the reality of where we live. Look at this shit. And you guys are scared of drones in the sky. You're scared of drones in the sky, huh? Uh-huh. Oh, okay. Oh my god, this is insane, dude. 2008, 2009, skip ahead a little more. It goes up to 2015. Look at this shit. Hi. Yeah, we're pretty much dead. Look at all this shit following us, but it behaves exactly like you think it would. Physics. It's pretty dangerous out there, dude. So let's hear the author of this video actually explain it. And it's a short video, it's only about 3 minutes. Here it is.
Hello, this is Scott Manley, and I'd like to talk you through this video I created showing the rate of discovery of asteroids for the last 30 years or so, starting in 1980. Now what you see here is a top-down view of the inner solar system with 4 planets in the middle, and on the edges you can see Jupiter. What you also see is a large number of green, yellow and red spots denoting the position of asteroids. The colouring is primarily to indicate how close they can come to the Earth. Green are main belt asteroids, yellow cross the orbit of Mars, and red cross the orbit of Earth. Also, as asteroids are discovered, we flash them white to make them more obvious. Now, if you look in the bottom left, there are 2 numbers. The first is the year, and the second is the number of asteroids known on that date. Now, you can see this number grows as more objects were discovered by astronomers. In addition, the highlighting of the discovery location lets you see patterns in the discovery process. The most obvious pattern is that most objects are being discovered opposite to the direction of the sun. And this of course makes total sense, since you're going to be looking for these things in nighttime skies. Sometimes you see a big flash of discoveries lined up with another planet. Scientists were perhaps looking for new moons around these planets, but found asteroids as well. In the 1980s, most imaging is being done with photographic plates, but by the time the mid-90s roll around, electronic imaging becomes the standard. This gives a significant increase to the discovery rates, since the turnaround time for image processing and analysis gets much faster. When you're trying to discover objects moving across the night sky, it's very important that you follow up on the observations before the object moves too far and is lost. Now, by the late 90s, a number of dedicated asteroid discovery programs are in full flow. These combine electronic imaging with automated image processing and follow-up. Hundreds of new objects are being discovered every day, and new patterns of discovery become evident. If you watch, you can see the discovery rate pulsing roughly twice a second. This corresponds to the lunar cycle. During a full moon, it is harder to discover faint objects since the moonlight makes the background sky brighter. There's also a sparse dead spot around the 5 o'clock position. Apparently this corresponds to the cloudy season in Arizona, where a number of these automated surveys are based. Now, by mid-2000, we're starting to see hundreds of thousands of known objects, and it's getting very crowded in the inner solar system. But you need to appreciate the distances here are huge. 1 pixel at the highest resolution is still 500,000 kilometers. So all those objects apparently buzzing the Earth are still a long way out. And now for a few seconds you're going to see the discovery pattern of WISE, the Wide Field Infrared Survey Explorer. That was a space telescope designed to image the entire sky in infrared. And so we're almost up to the present day, and we have over 500,000 asteroids in our database. I'm Scott Manley, thanks for watching.
Yeah, it's a real thing, dude. Now, this is what science brings us. I know, I don't think we do either. Now, my point of showing this is that this is what science gives to us. It lets us know of our circumstance for real in this universe. Now, I try to tell TI specifically about the scientific method and how observation works and how you have to... Well, I'm not going to... Forget about me. I'm going to let Maddox, the famous Maddox, explain it to you.
If you've ever talked about something you believe in with a group of people and everyone suddenly got quiet, you might believe in bullshit.
He's fucking great.
Special in the universe, I'm Maddox. A lot of people seem to think that they understand science, or that they're scientifically minded, or at the very least that they're rational. They prove it by boldly joining Facebook groups for people who claim to not only love science, but fuckingly so. But claiming to love science without actually having a scientific understanding is like claiming to love writing without being able to read. And a disturbingly large number of people believe in bullshit precisely because they have no scientific understanding. Here's how you can tell if you believe in bullshit. Just look at the steps on this board of the scientific method to see where your beliefs break down. Step 1 is to make an observation. Step 2 is to ask a question about what caused your observation. Step 3 is to form a hypothesis that potentially answers your question in step 2. And step 4 is to test your hypothesis and either accept your theory or reject it and go back to forming a new theory that you need to test again. Now let's use this method on a number of common beliefs that sound like bullshit. UFOs. See a light in the sky that you can't explain? Congratulations, you've just made an observation. That's step 1. Step 2 is to ask a question like, what's the source of the light that you saw in the sky? So you form a hypothesis, which is step 3. You're a shrewd observer, so you might think that the source of the light might be extraterrestrial in origin. Step 4 is to test your theory. This is where your beliefs break down, because unless you have evidence that the lights in the sky are alien in origin, you can't conclude that they are. Not knowing what caused the light isn't enough evidence to prove that what you saw is alien in origin. Time to come up with a new theory, preferably one that's not bullshit. Vaccinations cause autism. So you've observed that some people are born with autism. Good job, that's step 1. Next, you ask the question, what caused it? You think that it's vaccination. Now it's time to test your theory. You know that some kids who've been vaccinated develop autism, but you haven't controlled for all the other variables, such as diet, genetics, environment, chance mutations, related disabilities, or simply the higher diagnosis rate due to greater awareness. Plus, you can't explain why the 99% of people who have been vaccinated didn't develop autism. Oops, that's a shitty theory. Go back to step 1. Elvis and Tupac are still alive. You've never observed Elvis or Tupac alive. You didn't even get to step 1. Electromagnetic hypersensitivity disorder. People who believe they have sensitivity to electronic devices claim that electronic signals from Wi-Fi, cell phones, and even television can cause them to experience headaches, fatigue, and even heart palpitations. So there is your hypothesis. Oh shit! You got an Occam's Razor bonus card. Occam's Razor states that the simplest solution tends to be the right one. The symptoms you experience with electrosensitivity are identical to the symptoms of anxiety and stress. Would you like to change your hypothesis? Then it's time to conduct an experiment. But you don't even have to, because scientists already have. Over 46 studies were reviewed in 2009 in the Journal of Bioelectromagnetics, and they found that people who were exposed to electromagnetic signals were unable to determine when the devices were turned on or off.
Unable to replicate this phenomenon on other control. Oh, I'm sorry. Did you
Magnetic
lose?
signals were unable to determine when the devices were turned on or off.
You can't
Bad
do it.
hypothesis.
Oh.
Could have been Occam's razor.
That's sad.
What an idiot.
Yep.
Chemtrails. This one's easy. Ever see these in the air? Well, there's your observation. What caused it? Well, that's the question. Now comes the hypothesis. Some people believe that it's not the known phenomenon of warm jet engine exhaust mixing with cold air that forms condensation trails, but rather chemicals intentionally being sprayed on people by the government. No problem. Let's just test this theory. And oops! You can't test this theory, at least not without a helicopter and a way to scoop up a sample of a contrail to test it against a control group. Go back to the start. And by the start, I mean kindergarten. Hopefully this gives you an idea of where your beliefs fall apart, usually around step 4. If you can't test your theory, it's probably bullshit. That's it for now. Until next time, I'm Adam. If you've ever
Oh, man. He cuts right to the core.